Let's do a forward scan. We start with 0 here, and so 0 plus 4 is the earliest starting time for activity D. 4 plus 1 is 5, and 5 plus 3 is 8. On the other hand, if we go along activity B, 0 plus 4 is 4, and then we could go along activity E or continue with activity C. And if we go along activity E, it's 4 plus 4, 8 here, and otherwise along C, 4 plus 3 is 7 here, and then 7 along activity F, 7 plus 4 being 11 here. We choose the bigger number, 11, and then 11 plus 2 is 13. We choose 13, and 13 plus 6 is 19 is the minimum completion time. Doing a backward scan, we start with 19 here, and we know that we're going to be making choices here, here, and yep, those are basically the places we're going to be making choices. So 19 take away 6 is 13. Now if we go backwards along activity G, 13 take away 3 is 10, 10 take away 1 is 9, and 9 take away 5 is 4 is 5. And then if we go along activity H, 13 take away 2 is 11, and if we go along F, 11 take away 4 is 7, and 7 take away 3 is 4. Because we're making a choice, we write it here. Along activity E, 11 take away 4 is 7. And so we choose the smaller value, which is 4, and 4 take away 4 is 0. And we choose the small. So that is a backward scan. Now we are told here that the maximum reduction in time for each one of the 5 activities A, C, E, F, G is 2 weeks. And the cost of reducing the time for each activity is 5,000 per week. So now let's find out which of these activities and by how many weeks we're going to be reducing them. So what I usually do is I highlight the activities that can be reduced, which is A, C, E, F, and G. Now, in the forward scan, if we are to minimize the minimum completion time, during the forward scan, we need to actually crash activities. So let me indicate as to where we're going to be making choices while doing the forward scan. So we made choices here, and we made choices here, and yeah, those were the 2 places we made choices. So if we can reduce activity A and G by 2 weeks, currently what we have is, so let's say we reduced A by 2, so we have A2 here, and that takes this up to 2 here, and 2 plus 1, because D is not a reducible activity, will take us to 3 as the earliest starting time for activity G. And if we did reduce this by another 2, it would take us to G1, and 3 plus 1 would bring us down to 4. Now the important thing that we should see while doing this analytical targeted approach scan is that it is the larger value where we made a choice that we need to reduce. So reducing these activities is actually of not much use. So if we, let me highlight the activities that we can reduce. So it's 4 plus 1, 5 plus 3, and we had 8 here. And this was where we can first change values, because as you can see over here, E, C, and F, all three are reducible activities. Now it was 4 here, and if we went along activity E, the choice was 8 here. Whereas if we went down C, it was 4 plus 3, 7 here, and then 7 plus 4, 11 here. Now, 11 being the larger number, we definitely can crash activities C and F. And because it's a maximum of 2 each, if we did reduce C to 1 and reduce F to 2, that is 2 weeks each, we would get 4 plus 1 for C, which is 5, 5 plus 2 for F, which is 7, and we could change 11 and bring it down to 7. Now, if we bring this down to 7, we can clearly see that 8 is still the larger choice, and E being a crashable activity, we can take this down by 1 week and reduce this down to 7 as well. So now 7 is the earliest starting time for activity H. And 7 plus 2, because H is not a crashable activity, 7 plus 2 is 9. Now, is it any use crashing activities A and G at all? Not really, because regardless of how much we crash A and G, we will still choose 9 as the earliest starting time for activity I. And that brings us down to the minimum completion time of 15. So now if we record all the activities that we did crash, we crashed C by 2, we crashed F by 2, we crashed E by 1, and that was a total of 5 weeks. And if it was $5,000 per week, that is $25,000 incurred in order to reduce the minimum completion time to 15 weeks. Thanks for watching.